All right, and just a few minutes past the hour, we start it's actually not the first session. This is you probably notice in the invite, it says 337th session. This is a group that I started during COVID, and I've been just hanging out with my Spanish-speaking friends from Latin America. And we decided to start delivering the training, this Wi-Fi design training, a few months ago. Actually, I started doing it in Espanol. And then some friends say like, hey, how come you're not doing the same thing for us, people in English, you know, the English language? Like, well, that's not a bad idea. So I decided to deliver this training also in English. Now, my dear friends, I have, beautiful people here from Russia, from Denmark, from Argentina, from Italy, from where else do I have people in here? Let's see. It helps me if you guys show me your beautiful faces, not just a whole bunch of names there. I don't know if it's a robot. Ooh, from Sweden. Here we go, look at that, Boris and Pavel. This is great. Ahmed Mustafa. Sound like you're from over there in the Middle East.
Saudi Arabia, yeah.
Saudi Arabia, see? Oh, man.
Yeah.
Well, welcome. Why are you here, Ahmed? What's your story?
To see you.
To see me, oh, hi.
Yeah.
Mission accomplished. Ali, Shakur,
yeah.
Shakur. Where are you based?
Sweden.
Sweden, all right, welcome. Dipal or Dipal?
Yeah, I'm from Australia.
Australia, all right. Well, I guess you're going to be the queen of Wi-Fi this week, ma'am. Look at all these other beautiful guys and no girls. All right, welcome. Thank you for coming and making us company here. I know this is kind of like a male-dominated industry. In every class I ever had, it was rare to see girls, but hey, thank you. Yeah, you're probably the only one.
I know.
Yeah, sweet. Mark from Texas, huh? All right, it's early for you, Mark. I had to wake up today at like 4:30 in the morning. Honestly, like at 3 in the morning, I was looking at the clock, making sure I didn't, fell asleep, because this is early, and I had to take my daughter to class. She's driving, so I had to drive her to school, and she had a driving lesson at 5 in the morning. They have to do night driving. That's part of the training. All right. Now, it's not about me. This is about you. You're here. You have your story, and let me just tell you and be clear with you. This class is the class that for over a decade we've been teaching people from all over the world. Many of you probably I already met in either one of our conferences, WLPC, or through class. Anybody here I had in class before?
Yep.
Okay, Frederick, good. So you're here just to refresh knowledge? Or you're just bored?
No, I think that you get never tired of the basics in Wi-Fi design.
Oh, yeah. And you know me, I don't like to waste my time, as I said in the email, and I will not waste your time. It's valuable, it's precious. And if you're here, it's because you want to learn something. We're going to learn something, all of us. And do not think that because this is a free class, I'm just going to give you like, some free little things. No, this is the full-blown Wi-Fi design class. As a matter of fact, this is going to be better than the official ECAHAU classes I taught before, because I'm not teaching an ECAHAU class. I don't have ECAHAU, telling me what to say and what to do. This is just my class, and we're going to be talking about everything else. Not just ECAHAU. Yes, I'll teach you about ECAHAU, but we're going to learn about, let me just share my screen here, and let's see if I have this window. Move this window out of the way a little bit. Oh, if I can. Thing is moving all over the place except where I want it to go. Let's put it right here then. since it doesn't want to cooperate. So the people that used to be at Ekahau, they left, and now they have created this other company called Hamina. I don't know if you heard of Hamina, but this is the best #1 design tool. And yeah, it's not a Hamina class. Now you're going to say like, oh, see, now he's going to tell us about Hamina. No, they are the best at design. But the best one, the best company right now for surveying Wi-Fi is this company called Tesos. That's how you say it right, not Sidos, as some people say. It's Tesos. And then in this one I have come to learn about, and I interacted. This is also another company that comes from people that used to be at Ekahau. So these ones we have, let me just probably go back to another one. Yes, like very impressive for Nate, 2 APs in there. Let me just go over, and I have multiple. They have changed the interface recently. Holy smokes, look at all this. Okay, here we go. This one will work. They have a really cool tool, the best tool in the market. I know, better than the Psychic, better than the Nomad, better than anything out there. Because this device is called the Wave. And this device is a, let me just probably stop sharing here for a second and I'll come back to the screen. And I'll be sharing, not sharing, sharing, not sharing. If I'm talking about something in the screen and I'm not sharing, tell me, stop me. Say, hey, Fernay, you're not showing anything on the screen, man. Then I'll say, oh, sorry, let me just go back. So this device has antennas up here, and this is what's used for surveying with Tesos. It has a touch screen with a whole bunch of micro apps. You can do packet captures by itself. You don't need a phone or a tablet or a computer connected to it. You can just do this by itself. There's a whole bunch of micro apps. And it also has an Ethernet port. You can plug this to a cable. You know, sometimes you're doing a survey walking around, and then you have a cable, the IEP, you can just plug it in and test it. And it will tell you you have PoE, and it will tell you if it gets an IP address and what IP address on what subnet. It's really cool because this standalone device can be used without logging in, without an account, without anything, and you can share it. Ali, you can use it, and then when you're done, you just ship it to Dan uses it over there, and then ships it to Pavel, and then, it can be shared. One thing that we cannot do with other tools. So, yes, Hamina's #1 in design. I would say that's, and again, that's my opinion, Tesos is pretty good when it comes to surveying and the amount of data it provides. There is also another tool. See, this is a survey that was done with this guy. Let me just make sure that I probably have to select a different network and change the settings. And if I select, let's say, an access point, and I go to the settings for this guy, for the details, it's going to provide information on each SSID, each channel, what BSSIDs it has, the type of security, the type of encryption it has. Look at this guy. This is a WPA2, WPA3 SSID. That means it's in transition mode. See, other tools will not show me this. Ekahau is not going to show me this. Yes, Ekahau is the most known tool in the market. I trained many of you on Ekahau. That's how I met you. But then Ekahau is kind of lagging behind, and then now other tools are coming on top. And yeah, there is a price issue also because these ones are more expensive. Ekahau, Mr. Parsons has a document. Down the road in the class, I will share with you that document. There's another tool. It's called WLANPros. That this one, well, I won't say, I mean, it's not a complete solution yet. It's in progress. But then, oh boy, let me see if I have my, oh, here we go. My Fernay 75 account in there. And then, with this tool, get ready, because not only I can do designs, okay? Let me see if I have a design over here that I've done. Tesos, Edificio. Let's try this guy. I haven't used this in a few weeks. But with this stuff, let's see. Oh, you know what? Let me move this window out of the way. Oh, here we go. I could move it now. All right. Hang on. Give me 1 second. Be patient, Dan. So this tool does stuff that I cannot do with Hamina. I know. I just told you Hamina is like #1. And these guys, they have some things like if I want to draw a round thing, like this building stuff, they were doing it before Hamina made the announcement that, hey, you know, we can do buildings. These guys, you know, I was just putting together buildings like this. Look at that. And doing design with this. So this is great. This is a less expensive tool. And for design, yeah, we can do design. There's like a lot of people doing tools nowadays. But guess what? The best part is not the design portion. The best part is that with an Android phone, I can do a survey. Just with the phone. No, here, let me just bring up one of the surveys I've done. If I go back here, let's see if I remember. If I go to surveys, hey, this is one I did here near my house. Let's see, 454 points. I put my phone in the car and using Google Maps, I drove around. See? And it was just boom, 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 leaving all the dots. Oh, where did my stuff go? It was all right there just a minute ago. And then I just did a survey with just the Android phone. No Sidekick, no Nomad, no Wave, nothing. No external device. Just using the Android phone, I could accomplish the whole survey. Okay. This is just kind of like the preamble of what we are going to be doing here in this class. We're going to be talking about every tool that is out there. Well, not every tool, because I won't be using IB Wave, but here, where'd my window go? Oh, here we go. But we're just going to be talking about all the tools out there without the restrictions. Oh, I cannot say that because, you know, legal is going to send me a letter, and, you know, that's not how it's going to go here. We're going to be just sharing knowledge. I'm no expert when it comes to Wi-Fi. I know a little bit. I'm learning. But the little I know, I'll be sharing with you during this class without, you know, being secretive. Oh, I can't tell you about that. It's secret. No, I'll just share with you because knowledge is what we're doing here. Knowledge transfer. Wi-Fi design. That's what we're going to be doing. And again, this is not going to be less than any class out there. It's actually more, because that's what we're going to be doing. Happens that I come from the wired side of things. This data closet has a whole bunch of switches down here at the bottom. Have you seen anything like this before? Have you created something like this before? Yeah. Happens that down here there are switches. I used to work at school districts, and in some schools I had 8, 10 of these data closets. And then the patch panels are up here. Down here there are the switches all stacked on top of each other, and sometimes a switch overheated. It died, and then we had to remove 2 or 3 switches to get to the one we wanted. And then tracing cables, trying to figure out where it went, no documentation anywhere. It was kind of a nightmare. It was really difficult. So out of desperation, I started, and even before I knew about this one-to-one switch patching, I was doing it out of desperation. Because it's like, I cannot work with these things. It's a big mess. So I started cleaning them up in a way that I would have patch panel, switch, patch panel, switch. And then I now can see my 10 gig uplinks, my DAC cables. I can now see the fiber optics going to other data closets. And then my core and edge components will be down here. I can see the switches. And interestingly enough, My switches didn't die anymore. They didn't overheat as much. Why? Because now I had 2 rack units in between them, and air circulation was better. And if a switch failed, I just needed to remove that switch. I just unplugged these little 30 centimeter or 1 foot patch cables, and there it was. Very easy to do. That's a wire network closet before and after Fernay touched it. I started using different colors for different components, APs or any special component that needed attention. I could just go into the closet and I could point out, I know exactly what that is. That's an AP, that's a camera, that's whatever. And I started posting before and after pictures in every data closet. And I got the school tech and said, look, that's how it was. This is how it is right now. Let's keep it that way, huh, Tom? Because, you know, it's easier to troubleshoot. It's easier to come and look. And then I could show my supervisor, like, look, this is what I did. And then you could show your work. Now we move to these wireless networks. This is a professional development center. My office was like on this side. And then you could sit like 300 people there for training. Complaints about the Wi-Fi, it's slow, we have to go this, we go there. And that's the wireless network before and after I fixed it. Computer lab. Complaints, the students have to log in again, it kicks them out, they have issues. That's the wireless network before and after I fixed it. These wireless networks you cannot see. These wireless networks you cannot touch. These wireless networks you cannot hear or smell. Yet, we are in charge of buying them. We are in charge of selling them. We are in charge of configuring them. We are in charge of doing troubleshooting in these types of networks. We need not only tools, yes, we do need tools that would help us perceive these networks that our senses cannot perceive. We're going to be using Ekahau, we're going to be using Cetus, we're going to be using Hamina, we're going to be using WLANPros, but that's down the road, because first what we're going to be doing is learning how Wi-Fi works. If we don't know how Wi-Fi works, how are we going to be able to configure it? If we don't know how Wi-Fi works, how are we going to be able to do troubleshooting? Frederick, you have a car?
Yes.
All right, let's say your car, the brakes are failing. Let's say you take it to a mechanic. And the mechanic said, well, Frederick, I don't know how brakes really work, but hey, I'll just look it up on YouTube and, you know, I'll figure it out. Just come back at the end of the day, I'll have your car ready. Will you trust that guy to work on your car? On the brakes?
No.
Not really, huh? Kind of scary. So if you don't know how it works, how are you going to be able to fix it? If you don't know how Wi-Fi works, how are you going to be able to fix it? It's no different. It's just that it's not as scary. Well, it can be if we're talking about the Wi-Fi at a factory or somewhere that the lives of people are in danger. It's critical. And we are being entrusted millions of dollars worth of equipment. And I go to places to do so, here, get your tools, I'll show you how this works. Like, oh yeah, and then they get Wi-Fi Analyzer on Android, you know, a free tool to scan networks. You have Wi-Fi Analyzer? It's free, right? You're like, what else do you have? What tools do you have? Like, oh no, my company will not approve buying, you know, those expensive, you know, tools. Like, you have like millions of dollars worth of equipment and a free tool is all you have? We have to get new, good tools. So that's one of the things we have to learn first. Before we start doing Wi-Fi design, we have to know how Wi-Fi works. Or how else are we going to be able to design Wi-Fi? We don't know how it works. And here's the other thing. Wi-Fi has a lot of problems. The biggest problem that Wi-Fi has, you guys making notes? If you're taking notes, write this down. The biggest problem that Wi-Fi has is that it works. That's a big problem. Who has ever terminated one of these cables? An Ethernet cable. Ali. If you, inside, go ahead and unmute yourself. This cable has 8 wires inside, correct? So let's say you're talking to Mauro, and without even paying attention, you get those 8 wires, put them in the connector, and crimp it. Now you're talking to Boris, get the other end of the cable, cut it, get the wires, put the end in, and crimp it. Is that cable going to work?
50-50.
Yeah, highly unlikely. And they're going to say, hey, Ali, thanks for the cable, man, but it doesn't work. This is binary. It works or it doesn't. Then what are you going to have to do? Now you're going to have to cut and go and pay attention and put in the right order. White, orange, orange, white, green, blue, right? And you have to put in the right order, and then you have to cut them even, and then you have to put them all the way, and you have to crimp it right to make it work. Wi-Fi is not that works or doesn't. Wi-Fi always works. Alan, right? Is that easier?
Yeah.
Don't worry, I've been butchering everybody's names today. You got people from Russia, from Sweden, from Norway, from Argentina, de la tierra de Gardel, ¿no? El tango.
Correcto.
Muy bien. Y la carne, good steak over there. So people from all over the place. So welcome. From Canada, right?
Right.
All right. So, muy bien, muy bien. So, having a lot of fun here, because guess what? We're doing a free class. I know. Imagine that. Like, for free. It's like more fun when you do it for free. You have no pressure. So, if an access point is designed to be mounted in the ceiling like this, and it's mounted on the wall like a clock, it works. Just drop the metal plate. If it's mounted upside down, it works. If it's mounted upside down inside a metal box, it works. If it's mounted upside down inside a metal box above the ceiling, it still works. That's a big problem, because Wi-Fi was designed to always work, because it's an unbound medium. So now we have people that say, oh yeah, Wi-Fi, hey, you know Wi-Fi? Yeah, I know Wi-Fi. I said it, I have Wi-Fi in my house. Did you set it up yourself? Yeah. Oh, you know Wi-Fi, boom! Now you're in charge of 600 access points in 3 buildings in 4 countries. Because yeah, you know Wi-Fi. It's so easy, you plug it in and it works. And that's one of the big challenges that we have. We have networks everywhere that they just work. And what's the most common complaint we get when it comes about Wi-Fi? It's slow. Yeah, because Wi-Fi was designed to go fast or go slow and dynamically switch modulation, go up, go down all the time. Every single transmission, they have to make all of these decisions. Other big problem that we have with Wi-Fi. Wi-Fi is counterintuitive. Where did my girl go? See, she just disappeared. Dipal?
Yes, I'm here.
All right. Where's your camera?
Oh.
Come on, girl. Jeez. Like, camera bro. There we go. Okay, Dipal, I need your help with this. I have a couple of rocks right here. I don't know if you can see them, a couple of stones. Let me just, here we go. Can you see them?
Yep.
Okay.
Yeah.
Based on the knowledge that you have about natural phenomena on this planet Earth of ours where we live, and don't Google it, don't call a friend, just based on the knowledge that you have, what's going to happen to these 2 rocks once I put them in this glass with water?
It's gonna sink.
They're going to sink! Except, there is one that is floating.
Floating, yeah.
Oh, now we can get into discussions. Oh, well, you know, the density of the rock and is porous, is lighter than, okay. Per definition is a rock, is a stone, okay? What we know is that you throw in the water and they sink, as the other one did. Man, I have a lot of bubbles in this thing. Don't worry, this is not vodka or anything. This is just water. Hang on. There we go. Now we have no little bubbles. See, there's one on the bottom. You see it?
Yeah.
And one is floating over here. Per definition, they are rocks, and what we know is that you put them in the water, they sink. Except that now there's one floating. Our mind tells us they're going to sink. It tells us one thing. But then in reality, boom, something else unexpected happened. This is how Wi-Fi works. Wi-Fi is counterintuitive. We think with our mind that it's going to do something, and it does something else. Something unexpected. Maxim! How's it going, my friend? Welcome. Happens that Wi-Fi is counterintuitive. Our minds think it's going to do something and it does something else. How do you explain to somebody that in order to have more Wi-Fi, you need less access points? What do you mean? The Wi-Fi was really slow and we had budget, so we bought more access points. And we put one in every office. And we put one out there by the kitchen. And we put one everywhere. And it got slower. And since we had more budget, so we bought more Wi-Fi, more APs, and we put one in the hallway, one in the other, one in the everywhere. And there are so many APs. And we have slower Wi-Fi. How's that possible? Yeah, I know. That is two rocks in the water. We think it's going to do something, it does something else, unexpected. We have to know how it works so we understand these things. People think more APs, more Wi-Fi, right? No, not necessarily. Now, Tom, what sounds better? High gain or low gain? You can unmute yourself because I'm really bad at reading. Yeah, you, Tom, there are no more Toms in here.
Wasn't sure. I think it depends on the environment.
Don't think what sounds better, high gain or low gain.
Probably.
Why are you thinking?
Low gain to control the RF in the environment.
Yeah, see, he's getting now all like, oh, like, what sounds better, high gain or low gain? I probably chose the antenna guy to answer this question.
Sounds better is high
High
gain.
gain.
High gain sounds better. Why? Because it sounds better. And people say like, yes, we need high gain antennas. Like, why? Well, because high gain is better than low gain, isn't it? Like, well, not necessarily, see? Because it depends what you need it for. We'll learn about this as we go in this class because those are misconceptions, counterintuitive concepts that people out there think that, high gain sounds better than low gain. Eduardo, Eduardo. Vamos a ponerle Eduardo.
Yeah. Hello.
Eduardo, what sounds better? Active survey or passive survey?
Active.
Active sounds better. Why? Because the word itself sounds more active, more attractive, more active. And people will tell you, I need you to do an active survey. Like, why?
Yeah.
Well, because active is better than passive, isn't it? I mean, passive sounds too passive. How do I do a passive survey? Active survey sounds better. And then people will demand it. Oh, in the RFP it says that you have to do an active survey. Why? Well, it sounds better. The word itself has a positive, more active connotation. Two rocks in the water. We never do active surveys. We always do passive surveys. What's the difference? Well, that's why we're here in class. We're going to learn why one is better than the other and what exactly would these things mean. Wi-Fi is counterintuitive. Wi-Fi has a lot of problems, but Wi-Fi is a wonderful technology. That's what keeps us going. Let me just share my screen. In my screen, new screen again. Okay. Then now, this is me, Ferney Munoz. For those of you who do not yet know me, I'm originally from Colombia. And I moved here to the States back in '99. I came to visit some friends that I met when I was a kid, and I ended up staying. I've been working with technology since 1987, 1988. Mila! Welcome, Mila. Sorry, Deepal, you're not the queen of Wi-Fi, but you're still the queen. Mila is the princess of Wi-Fi. See, now we have two ladies in here. That's good, that's good. That's 2 out of, 28. That's good. Thank you. So, I started working with technology and then networking, and I used to work with all kinds of stuff, back in the day doing fax modems and IRQs. Remember those? Doing the jumpers on the printer cards and all of those. When I moved here to the States, I started working at a school district as a volunteer. Let me stop sharing my screen here for a second. And I had, we had about 550 of these Apple access points. Let me just bring this up in here. I'm gonna have to undo my little museum. I have a whole bunch of junk, says my wife, but I'll say this is just a beautiful piece of stuff. I know I'm the only one, but I just find this fascinating. So we had like 550 of these guys. Remember those? Oh yeah. They started putting those for us in the USA. Remember CompUSA? Anybody? Tom, I know, by that white beard that you remember CompUSA. Where are you based?
I'm sorry?
Where are you based?
I live in Long Beach and I work in Irvine, California.
Okay. Oh, it's early for you. You're up early, huh?
Yes, sir.
Early.
Yes, sir.
Have we met before?
WLPC a couple months ago.
Oh,
Good.
good.
Yeah, we chatted a couple of times.
Oh, hi. Sorry, I don't remember people very well or names.
It's okay. This is mature blonde, by the way. It's not gray.
Ah, okay. There we go. I like that. When I have mine, they say like, "Oh, you're getting old." Like, no, I have kids and a wife. That's what gives me all this gray hair. So back in the day, people used to go to CompUSA and buy this stuff and brought it to the school, and then it started as a cool thing, convenient, because they say like, yeah, you just plug it in, and you don't have to have a cable connected to it. You just connect it, and then we ended up with 500 of those throughout the school. And then, of course, when you needed to create a new SSID, you had to do it in 500 of them, one at a time, because there was no way to manage all of them. Then later, we ended up with zeros. Remember zeros? These guys, I know this is a 12 radio one, but the ones were 4 radios. Actually, and this is actually a fascinating piece of equipment. Let's see if I can open this. I thought I had removed the cover from this guy at one point, but now, oh yeah, I know exactly what I did. Hang on one second.
Isn't that what Captain America uses?
Everything here is big size, man. Everything here is plus size. Look at these 12 radios. The ones we had were 4 radios everywhere. So, I mean, that was the best thing we had. That was an enterprise solution. It served us well. Yes, later, and with this one we had like 650 of these guys. And then later we moved to Ruckus. So we put a Ruckus or Ruckus, how you call it. And of course, even before in some schools, we had some of these Cisco guys. Probably remember those two? What model is that? The 1120s? They're really cool, Aeronets. And then I started getting into this Wi-Fi stuff because as many of us, Wi-Fi came to many of us because either somebody said so or it just started happening around us. And then we started dealing with Wi-Fi. Through that process, I met this guy, Keith Parsons, and yeah, I ended up leaving the school district, and the rest is history. I've been doing trainings, doing consulting, and doing just Wi-Fi stuff. I used to be in charge of servers and workstations and firewalls and switching and routing and VoIP. We used to change from PBX systems to VoIP systems back in the days of 3Com, and we were installing NBX 100s. Remember those? Any of you guys? Yeah, 3Com, doing VoIP, and yeah, we had to learn all that. So I had hands on everything, but I was not good at anything. I mean, I'm still not good at anything, but I know a little bit more because I dedicated myself to Wi-Fi. That's what I do. But we, along the way, have to know about other things, not just Wi-Fi, because it's a whole complex system. So that's what we're going to be doing in this class. And again, for those of you who came in late, because this is a free class, it's not going to be any less than the full-blown classes I've delivered to many people throughout the world. It's actually going to be better because we don't have the rush that we have. We have just an hour and a half and take a break. Like, no. We're just going to go finish the session, and then, I'll send you another Zoom link to join me on the next session. Maybe it's going to be tomorrow morning. Maybe it's going to be some nights. Maybe it's going to be on weekends. Okay? Because that's how we roll. The ones in Espanol, I've been doing it like Saturday mornings, Sunday mornings. In the weekend, like all this week, we've been doing Hamina at night, just an hour here, 2 hours there, and that's how we start compiling them. And if you cannot make it because you're in Australia or because, you have some commitment, then it's going to be recorded and uploaded. I will warn you, there are some things that sometimes we show, maybe something about a client, about a project that I cannot show or record. I mean, that I cannot record and leave it out there in public. Then I'll pause the recording, and then I will discuss it, and then we'll continue recording later. So if you're not here live, you may miss some of the discussions we may have. Let's say Maxwell has questions about a project he's working on. We'll help you. But then we'll stop the recording because we're not going to compromise anybody's personal data or any confidentiality. We're going to respect it, and then we can help you. And then once we're done, we continue recording. Does that make sense? Does that sound fair? Okay. I will also get you licenses for Hamina, for CEDOS. Hopefully I'll try to get some Ekahau licenses so that we can learn how it works and stuff. So these companies, hopefully they will all share with us. The ones we've been doing in Espanol, we're almost towards the end of the class. We've done over 44 hours now of training and just uploading everything. I think this is good for the community, good for everybody. There are many people that want to learn more about it, but classes are too expensive. $2,000-$3,000, it just starts getting expensive. So we're going to try to make this accessible. And if you don't like class, I'll give you a full refund. Full refund. Okay. Why Wi-Fi? What's happening with this thing? That's not me here. Let me just go back to my presentation. There we go. I live in Utah. We don't have any more snow anymore. Well, there is some snow up in the mountains. But that's where I live, in the mountains in Utah. So why Wi-Fi? Happens that Wi-Fi is everywhere. Nowadays, that's the technology. People use the term to refer to the internet. When they say, oh, Wi-Fi is not working, like which part of the Wi-Fi is not working? Maybe it's the server that is down. Maybe it's the modem going out to the internet that is down. Maybe a power or not, but simple explanation, Wi-Fi is not working. Wi-Fi is everything. Wi-Fi is everywhere. They show that the troops, their morale improved because now they can be connected even if they are remotely in aircraft carriers. If you're in space, everywhere you can have Wi-Fi and benefit from it. Yes, a lot of we've done in industrial sites and some nuclear power plants. We had the privilege to be here in the US and in Europe working in nuclear power plants. And yes, there is Wi-Fi and other wireless technologies being used. They're not for critical components, but it's convenient, it's easy. Now, let's go to probably not a very sophisticated place. I know we're talking like space and aircraft carriers and nuclear power plants. Let's go to a place that is not as sophisticated, but also needs Wi-Fi. We ended up doing a project in the slums in Kawangware in Nairobi, in Kenya. And I was like, but what? I mean, it touched my heart. I said, oh, they're trying to put Wi-Fi out here in these less privileged areas of the planet. And that's great. And I said, but why do they need Wi-Fi in here? These places, and you see the Ukopoa, that purple stuff on the background, that's the internet service provider. And then I was just surveying. I had a couple guys walking me all over the place. And we were literally just walking up and down the slums and the streets. And this place, that is like right here, that's the sewer system. Like some of these places stunk, because that's the sewer system. And then the construction, look at all the metal and all the tin walls and fences and everything. That's a rough environment for RF. See those yellow barrels right there, that lady carrying on her head? That's their water. They buy the water on the streets because there's no like drinking water coming to your house. See, it was just big everywhere. At the beginning, I was like, what's that? Like, well, that's water. Like, for what? Like, that's the water that we have. This place had no sewer system, no water system, but they did have Wi-Fi. Or Wi-Fi, how they call it in Spain. The Wi-Fi, joder, tío. Isn't that interesting? And then, of course, I was like, but why? Wow, this is really cool. Everywhere I went, there were people using the technology. Before I even knew, here in the US, we have payment systems like Venmo and or PayPal or Zelle or any of that stuff. You in your countries, you might have your own. They were using systems like that back then to pay for stuff out in the streets, the stores. People were using that for entertainment. People were using that for, looking at the bus schedule, for buying stuff, for paying for stuff. Everywhere I went, people were using Wi-Fi. By looking at the heat map, the yellow parts, yellow-green, there's good Wi-Fi. And those are just the areas I walked. They just need to get samples in there. And then they wanted to know where there was good Wi-Fi. That's why I was doing a survey there. And where there wasn't. Because they wanted to sell Wi-Fi to people. Like, what do you mean sell? Like, oh yeah, we create an SSID, people connect to a captive portal, and then we ask for their money, and they can buy 1 hour of Wi-Fi, or 4 hours of Wi-Fi, or 1 day of Wi-Fi, or a week, or a month of Wi-Fi. And they're like, but where do you have your access point? Like, oh, no, we're using, people's modems in their houses. Like, are you giving them like a free modem, or like, oh, no. People have the benefit. They buy their modems, and they have their stuff. Like, but you're like, oh, what? They were creating an SSID and basically piggybacking. Do all of you guys understand that term, piggybacking? All right. Pavel is like, no, what is that? It's like when you, piggyback is like when you get a kid and then you put it on your back and the kid is like riding on your back. That's piggybacking. Okay, you're carrying someone on your shoulders, well, on your back. Piggyback is you create an SSID. And then it's like here in the US, we have Xfinity. That's a company that provides internet. And then you have an Xfinity SSID. That is not yours, it's Xfinity's. And then it's announced in every Xfinity modem. And then if you have an Xfinity account, you can connect. Maybe in your house, maybe you are in Frederick's house, but he's got Xfinity. Then through that SSID, you connect. Does that make sense? So they were just putting SSIDs on these modems and selling them. But you don't have infrastructure. You don't have that. So we have to know how this. Now, as a Wi-Fi professional, regardless or if you're in Africa, or if you're in the US or in Sweden or Russia or anywhere, as a Wi-Fi professional, you have to know about the regulatory domains. Okay, so here's the other thing about this class. We're going to be covering first how Wi-Fi works. And basically this is going to be CWNA training. Okay, everything that we're going to be covering here, you can use towards your CWNA certification. If you want to take that exam down the road later, all of this training is going to be helpful for that. But it also will be helpful if you are in Wi-Fi, if you're in technology. This is what you need to know, okay? Regulatory domains. Every country, every region has their own regulatory domain. Here in the US, we talk about the FCC, the Federal Communications Commission. They do not create Wi-Fi, they regulate, as the name implies. They regulate. And what do they regulate? Wi-Fi and FM radio and AM radio and satellite communication. They regulate even what you say in public radio or public TV, even what body parts you show. I don't know if you remember back in the, I don't know, remember that Jackson girl that was doing a halftime performance at a Super Bowl, that her dress came loose and, you know, some of her skin shown? She got in trouble for that because she showed more than she was supposed to by accident or not, I don't know. Then that was fine. They regulate everything. They regulate the airways. What do you say in public? All of that stuff is regulated. And yes, they also regulate Wi-Fi. They will tell you which channels you can use, what frequencies you can use, what type of antennas you can use, power levels, frequency, all that stuff is regulated by them. Eduardo, where are you at?
Yeah.
Where are you at? Where's your country? Is your mother?
I'm from Russia.
Russia! What's the FCC in Russia?
We don't have FCC.
Okay, but what is the equivalent?
Equivalent, it's, yeah, we do have.
You have to have something. Come on, Maxim. Let's get Maxim's or Andre.
It's called RKN in general.
Aircram?
RKN.
RKM. Okay.
Russian Communication Regulation.
Yeah.
Russia Communication Regulation. Okay. Sweden. Where's my Swedish friend? Ali, you're in Sweden?
Yeah.
What's the FCC of Sweden?
It would be the PTS.
PTS.
Yeah, I think they also handle, they do handle radio, and they also handle postal services. Like,
okay.
Like post office stuff.
In most places, it's a government entity that they regulate all that stuff. In Colombia, we have the Ministerio de Telecomunicaciones. Where's my Argentinian friend? Which is the FCC of Argentina?
The CNT is Comisión Nacional de Telecomunicaciones.
Comisión Nacional de Telecomunicaciones, the National Telecommunications Commission. So it's the equivalent, okay? So you have to know that whatever country you're in, there's going to be someone, some entity, private or most likely public, that regulates all this stuff, okay? Why is this important and why are we talking about this? Because when you're designing Wi-Fi, you have to know about what channels can be used, what power levels can be used. You have to know that, yes, maybe in your country, you can design one way, but if you're doing a design for a company in another country, you cannot just copy-paste a design from one side and take it over there. It's not going to work. Or maybe it will work, but with some restrictions. Maybe the power levels are going to be different. You have to know all of this. And you may say, oh, no, I only design my country. Well, hey, the world is flat. and maybe your company that you work for, they have branches in other countries. Keep this in mind. Questions about regulatory domains? No questions. Clear as mud. Okay. Easy enough? Does that make sense? Okay. When designing Wi-Fi, we have to know about that, because when we get to the designing part, then some channels are going to be available. And like in CDOS, remember I showed you CDOS earlier? You go there and then it shows you like channel 32. And we're like, channel 32? And I call like, there's something wrong in here. Channel 32 doesn't exist. Hey, doesn't exist in your regulatory domain. It exists in other regulatory domains. They use channel 32 and channel 96. You heard of channel 96? Anyone here uses channel 96? I know, but in some places they do. Is it APAC? I think it's somewhere in Asia that they use channel 96, channel 32, channels that we usually don't have. Okay, that's it for yeah, go ahead.
Let me interrupt you quickly. Is there a list where I can see all the regulatory domains worldwide?
I'm sure there is one out there. I'll try to gather some information and provide it to you later, at a later point. I'll gather a folder and then share with you later. I'm not going to post it online because it's just going to be for you guys here, okay? But then I will provide some documents today, probably in a little bit, that at least show the most common regulatory domains. Okay, so this is one of the entities that you as a Wi-Fi professional, either you're here now or you're watching this video later, as a Wi-Fi professional, if you're starting to learn about Wi-Fi, you have to know about regulatory domains. Find out what's the regulatory domain in your country. All the documents we find, they may say FCC. Well, that's what the FCC is, the regulatory domain for America, the US. Every country, every region is going to have their own. There is ETSI. It's in Europe, but each country in Europe is going to have probably their own, and then there is ETSI. Which one takes precedence? I don't know. That's for you to find out. Here's the other entity that you as a Wi-Fi professional have to know about. The entities that create the standards. And this is not new. This is not a new organization. Let me just take you back down history lane, because it started back in 1884. Thomas Edison, guy here from the US, worked with electricity. He said like, we're working with those electricity stuff. It would be nice if all of us electricians would gather and talk about electricity, and let's just create a standard so that we have a plug and we all build stuff to meet that standard. Or else everybody's going to have their own plug and it's not going to work, and then the voltages and the frequency and all that stuff. So they created the American Institute for Electrical Engineers. All these electricians gather and then they shared knowledge and came out with documents and agreements and stuff to create standards. Does that make sense up to this point? Okay, a little bit later, Marconi and these other guys that were working with radio signals and radio waves and electronics and diodes and stuff, they got and said, hey, it would be cool if us electronic guys gather and create a group like the electricians did. And then we'll just talk electronics and diodes and resistors and all the stuff that has to do with electronics. And they created the Institute for Radio Engineers, IRE. And same thing, they shared knowledge, documents, and came out to agreements and, kind of like build standards for electronic stuff. Both organizations kept advancing, growing, and happens that with all these computers and electronic stuff kind of like gaining more traction and like more varieties of it, then they decided down the road, so like, you know what, we're always like crossing paths, and of course we're dealing with electricity, and we're controlling electrons, and these guys are dealing with big electricity, we're dealing with small electricity and small components and stuff, but we're always like, you know, crossing paths. So they joined forces, and they created the Institute for Electric and Electronic Engineers. They created the IEEE about, you know, 1963. So the IEEE is an institution, international institution, where engineers, people, humans that have studied different sciences have come to join forces, share knowledge, and create standards. Again, this is formed by people. Ha! But people work for companies. And yeah, companies may send their people, they're going to try to push the company's agenda. Why? Because they want to say, hey, we want to be GE, came up with this standard and contributed to humanity by providing this. All right. But again, it's engineers, people. And companies send their finest and brightest and smartest engineers to create these standards. So far, so good? Okay. So with all these computational devices, computers, and let's say IBM created their stuff and created their plugs, and they wanted IBM computers to talk to other IBM computers, they created their own way to plug them in and communicate between them. Texas Instruments, they also created their own stuff and their own plugs and their own things to communicate Texas Instruments to other Texas Instruments devices. And life was good. Except that if you brought a device from Texas Instruments to IBM, they say like, oh yeah, no, we use a different plug, it's just, you know, we use different things, like you cannot connect to this network. So like, man, this is out of control. How are we going to make sure that like this device can connect on this network? Because right now they all have their own. They say like, no. We're going to have to create a standard for telecommunications. So they form this group, the 802 group. You know, it's engineers. They assign numbers to everything. And coincidence or not, they gather in February of 1980 to like ratify and solidify this stuff. And some people say, oh yeah, that's, you know, 80, the year, month 2, 82, 802. And they say, no, it has nothing to do with the month or the year. Okay, it's just a number, 802. So when we talk about 802, we are talking about a group of engineers, part of the IEEE, that were assigned just to work on telecommunications. And they say, hey, you engineers, really smart engineers, you're going to work on a standard for devices to communicate with other devices. And it doesn't matter if it's Apple or IBM or Texas Instruments who makes it. If they build that device to that standard, then you can just go in and plug in and then it should work because it's a standard. Everybody builds to that standard. And this guy Metcalf, he's the one that came out with this, hey, I have this idea about implementing this, and then they called that Ethernet. Remember that? So that was the third group. So the 802 is the main group, and then they created subgroups under that. So it created the 802.1. And then that group is in charge of maintaining the group and doing certain things. And then they created a second group, the 802.2 group. The third group they created, the third group, 802.3, they took that proposal from this guy Metcalf. What's the first name? Is it Rob? Bob Metcalf? The Ethernet guy? Bob, right? Okay, Bob Metcalf. He said, like, you know, I have this great idea, you're this, and then they said, oh, that's a good idea. So he submitted the proposal to the group. And this guy said, like, man, that's a really good idea. And then they got all these people working on that work group. And then the third group, what's the name that we have for that group? It has a name, I mean, because this is the engineering IEEE name. But the name for that group is Ethernet. When we talk about Ethernet, we're talking about this third group of people that were in charge. And they say, guys, We need devices, computing devices, to talk to other computing devices using wires. Any wires. This is Ethernet. And then yes, it's wires, and it can transfer at different data rates. All of those data rates, the voltages, the twist ratio, the number of wires, all that stuff is defined by the standard, by that group, by that committee. Yes, there was also thin net. Remember with coax cable? I had to crimp some of those cables and put the 50 ohm connectors at the end. Remember that, Tom? Put the, and then put in the T's, and when one of those got loose, you had to go trace it down and try to find out where it broke or if somebody unplugged anything. All the communications that happen on these cables, the voltages, pin outs, how many cables, wires, gauge of the wire, the thickness, all that is defined by the standard. 802.3. The fifth group, I think it was token ring. The group number 11 that they created, they said, guys, we need devices to be able to talk to other devices but using no wires, wireless. So that 11th group was in charge of creating standards for devices to talk to other devices wirelessly with no wires. So when we talk about that 11th group, we're talking about what? About Wi-Fi. We're going to talk about that name later. But when you see in a document anywhere that says 802.11, we're talking about wireless communication from devices to devices. Does this make sense up to this point? That's what 802.11 is. Okay. But it happens that within that group, they said, okay, we're going to use the 2.4 frequency. We're going to talk about frequencies and waves and all that stuff later. They said, we need to use 2.4. So they assigned this group of people and say, hey, guys, we need you to work on this in the 2.4 band. And then other guys say, like, oh, you know what? We can also make this work using the 5 gigahertz spectrum, a different frequency band. So they created subgroups, and they say, well, so how, we know that 802 is communications, telecommunications. The 11th group is for wireless, but if we're going to get more groups under that group for 5 gig, for 2.4, for other things, how are we going to call those groups? So like, well, 802.11.1? That's too many numbers. Why don't we use letters? So like, okay, let's use the alphabet. And then they created the 802.11 group. They were in charge of doing certain things, and then they said, okay, how are we going to call the first group? And said, well, we're going to call it the 802.11a group. I said, okay, yeah, we like it. The first group, 802.11a, was created, and they said, guys, you're going to have to make sure this device talk to other devices using 5 gigs, and then you have this spectrum, and then the second group, 802.11b, so we're going to make this work in 2.4, we're going to use this frequency, we're going to use it, and then they're going to have to work on that stuff. And then they started creating a group, and then what's next? Well, C, then 802.11c, and then all the way down through Z to Z. And then they run out of letters. It's like, oh, so how are we going to call the next one? It's like, well, I don't know, let's add another letter at the end. So they created the 802.11aa group, the 802.11ab, AC. Have you heard of 802.11ac? That's just another group of really smart people that were put together in a work group to work on a specific problem, find a specific solution for something. Some of these letters got lost. Like, for instance, 802.11f, as in Ferney. 802.11f. That group, they told this guy, like, guys, we're going to create a standard to allow a Cisco AP to join an Aruba controller. And what do you think Cisco said to that? Ha! Not gonna happen. However, being a standard, there is a standard for that. You can have a Ruckus AP join an Extreme controller. doesn't happen. They basically, that standard, that amendment to the standard was let go. They got to a point like, nobody's using this. I mean, it's a great idea. But people say, no, I'd rather keep everything in-house. APs that are Cisco with controllers that are Cisco, and then they work better. We can create a better solution that way. And yes, nowadays you have open Wi-Fi. You have a white box that you install a Linux operating system, and then you can put whatever operating system. You can have Action Tech access points join an edge core controller, kind of like the same principle. But then back then, they said like, nah, not going to happen. So there is one, but then that letter got lost. They said like, we create this group, and if things don't work, like for instance, back in the 802.11b days, networks could go at 11 megabits per second. So they had another group, I don't remember what letter it was, they said like, we're going to make that go twice as fast, 22 megabits per second. And they had all these engineers trying to figure out the electronics and how they're going to make this thing go at 22 megabits per second. And then the G group finished their work. And they said, we can make this in 2.4 work at 54 megabits per second. So if you have a group of guys trying to make this go at 22 megabits per second, and this other group finishes first at 54 megabits per second, it's like, what's the point? We're wasting our time. Then group dissolved, nothing happened. We don't have, I don't know what letter that was, C, I don't know what it was, but that's what happened. That's what all these letters mean. It's just another group of guys that were assigned to work on a specific problem. Questions up to this point? Comments? Insults? Anything? Nothing?
Perna, what is the best letter for you in this group of groups?
I would say the most significant one is N, 802.11n. That brought so many benefits and so much good stuff that I don't think, pretty much up to this point, one way or another, we're building on top of N. Yes, there's been some revolutions and things that came new with AX, things that were different, but I think the most significant one has been N. What do you think, Andre? Which one's your favorite?
My favorite is Z, but unfortunately it's reserved and will not be used, so.
Oh, all right.
I will wait for 802.11 Wi-Fi. It will be the perfect one, I think.
All right. What's yours, Boris?
Well, AX should be the best for me when it comes to 6 gigahertz only.
Yeah, I know that. That's a dream, huh?
Well, it's not the dream. We are deploying them.
Yeah, but it's not as straightforward because not all devices, not everywhere it's available. We'll talk more about this. We're going to start building up on this stuff.
Actually, we are thinking about making kind of, a funny thing. If you bring enough beacons, advertising, well, not that good original domains, Apple devices would switch off 6 gigahertz adapters. Mm-hmm. So basically, if you have a 6 gigahertz network in your office, and I bring a dozen of ISP32, well, just boards that are advertising Russian frequency domain, your Apple device will shut off its 6 gigahertz adapter, and your network will go and your network will go down. That's a funny thing. We'll get to that point. There's so much happening that, and here's the other big problem. There's so much marketing out there that is just over pushing limits, and we spend most of our time trying to tell people like, no. 46 gig? No, it's not going to work. That's like, no, it doesn't work. We're talking about like people putting, we need 10 gigs to every AP. Like, why? Well, because we have this technology, Wi-Fi 7, that is gonna, do so many gigs. Like, no, the medium is still shared. All right. Happens that all of these amendments, each one of these is an amendment to the 802.11 standard. Each one of these amendments you see on the screen have to do with the physical connection, with layer 1 stuff type of thing, like which bands and the widths of the channels and all of these physical layer stuff. There are other letters. Other problems came up. For instance, they say like, so what if, because we have different regulatory domains, so how are we going to regulate the APs that are going to be installed in Russia and the ones that are going to be installed in Argentina and the ones that are going to be installed like, oh yeah, that's right, because they don't use the same powers, same channels, same stuff. So how do we enforce that APs, if you are in a specific place, behave according to the local regulatory domains? So you're like, yeah, we need a group of really smart guys that know about regulation and all this stuff to work on an amendment. Hey, Maxim, what's the next letter available? And they said the letter D. Okay. The 802.11d group is going to work on this regulatory domain stuff. Coincidence or not that it happened to be a D? Huh? And then they say like, on the cables, on Ethernet, we have user priorities. We have DSCP values. And then if it's voice, those packets go out first. And if it's video, then they get a different priority. And then if it's background, then different priorities. QoS, right? They say, how are we going to prioritize traffic in the air? They said, that's right. We haven't figured that out. Because the people with voice devices, they're suffering because, the way Wi-Fi works. So, hey, Eduardo, what's the next letter? They look at letter E. Letter E is not being used, okay? The 802.11e group, those guys are going to be in charge of finding ways to prioritize this voice traffic in the air. That's the 802.11e group. How about security, Mauro? How are we going to secure these waves, these transmissions in the air? I said, that's right. What's the next letter? I said, letter I. I said, oh, the I, okay.
About other questions?
Yeah. They said, look, 802.11i, give me 1 second. The letter I, they just take care of security. How are we going to secure this? And then they deal with encryption and ciphers and all those different mechanisms. Those fall under the 802.11i amendment. Okay?
Yeah, I really have clients with have no choice to change the VPA to passwords elementarily. The name of the azienda, the name, no other, no enterprise, no VPA3, no other.
That's a challenge.
This is a layer over what you are doing.
So they don't do 802.11i. They don't have that amendment. Okay. Hey, let's take a screenshot here. Okay, everybody, show me your beautiful faces. Let's take a screenshot of the screen and just show the world that we're learning, we're spending time. Okay, come on. Hey, look at those beautiful faces showing up. I like it. Everybody, come on, Hando and Tomislav and Konstantin. See? Now they're like, oh, no. There we go. Hey, you can be all cozy there, man. How's it going, Hando? Where are you at? What's your story?
Nothing to tell right now. Sorry. Thank you for sharing your knowledge.
All right. Let's just take a screenshot right here. Let me just see. There are 4. And smile. Look at the camera going. Hey, Carlos Asuncion, turn your camera on, man. Come on. I just turn here. Everybody. Hey, Tomislav, how's it going, man? Looks. There we go. Ahmed, there we go. Okay, ready, set, and there we go. Now a cool picture right there. I'll share it with you later. We'll post it. All right, so up to this point, all of these amendments are just part of the standards organizations. They do not regulate anything. These entities create standards. The regulatory domains, they don't create anything. They regulate and let you know what power levels you can use, what channel width, what frequency spectrum you can use, what type of antennas, how high those antennas can be. All of that stuff, that's responsibility of the regulatory domain. The IEEE, they create standards. Those are the ones pushing BE and BN and BT and all this stuff that is happening with Wi-Fi sensing, with Wi-Fi 8 and all this multi-AP coordination. All that stuff, standard bodies. They just create standards. Whether or not it's going to be used, that's a different story. But they just create standards. And you, as a Wi-Fi professional, it's your job to know about all of them. And yes, to know that maybe some of these standards, somebody had a great idea and they say, oh, it would be cool if we can do this. And then they created a standard and maybe real life they say like, nah, this is useless. Nobody's going to use this crap. And then they don't implement it. Then it's there, but it's never implemented. Besides, here's the other organization, the third one, that you as a Wi-Fi professional should know about. Yes, for the IEEE, it makes sense that they use these numbers and these letters and all this stuff to refer to specific groups. But then you never go like to Mila's house and say, hey, what's the PSK for your 802.11 network? Like, how often do you have people coming to your house asking that? Andre, what's the PSK for your 802.11 network? What do people ask for? That's when I ask a question and any of you answer it?
The password.
The password for what?
For your Wi-Fi.
For your Wi-Fi, for the Wi-Fi. See? So Wi-Fi, Wi-Fi, because they say like, you know what? These numbers, it's kind of like dumb. I mean, it's engineers just putting numbers and letters and codes and things. That has no value to the average person out there. So, the same group of engineers in the IEEE, they realized that, yeah, maybe we should just, I don't know, create another group that, one, let's find a pretty name for this 802.11 stuff. Second, out of all of the things in the standard, all of these great ideas, let's see what of that we can build, test, certify, and sell to the people. We'll put pretty marketing names on stuff. And then there is a book out there about this guy, Greg Ennis. He wrote about the Wi-Fi history. What is the name of that book? I have it over here. Well, I have it somewhere. Oh, maybe I bought it digital.
Wi-Fi
the
everywhere?
Yeah. Wi-Fi everywhere? Is that what it's called?
I think so. I read it.
Okay. If one of you can find that link on, I don't know, Audible or anywhere, and paste it on the chat, I'll share it here with the group. So, once this group, now here's what they did. They said like, but let's not just be this of people, let's have companies be members. Let's just create an organization, an alliance, and we have companies participate. And let's say Apple signs up, and let's say Intel signs up, and let's say Texas Instruments signs up. They become members of this alliance, of this group, and then they say, the IEEE, we created this standard. It says that we can give priority to devices for voice and video. So they created this group and then they tested it and see if it's really, if you say you build this device and it's compliant and it can do 802.11e, like wireless multimedia, that's what the name of that is. They have other certification programs. They have like Wi-Fi Advantage, and they have Wi-Fi Halo is one of the certification programs. So they said like, okay, let's start with all of these standards, these amendments. How are we going to call them? And then it was later in time. It was not very, very new or very old. I mean, it was just at some point when the cellular networks were working with, 3G and 4G and then 5G, they said like, you know what? These guys are talking generations. Because when we talk about 802.11n, and then 802.11ac is coming, and then we had 802.11g, and then people be like, G, what G and what does that mean? We understand it because we study it and we know it, but the average person doesn't know about that. So why don't we do what the cellular people are doing? Let's add a generational name to it. And then at the time, AC was out. They said, well, let's call this, they're talking in cellular networks about 5G. How about we call this Wi-Fi 5? Okay, that's cool. So how are we going to call the last ones? And they say, well, the prior one, let's call it Wi-Fi 4. Okay. And the next one? Well, duh! The next one's going to be Wi-Fi 6. And then they had this group, this work group working on Wi-Fi 7 already. Okay? But in between, this other group, they made Wi-Fi 6, 802.11ax, the 6 gigahertz bands became available. Kind of like in between 6 and 7. And they said, like, oh, how are we going to generationally going to call this group? And they said, I don't know, Wi-Fi 6.5? No, that looks ugly. How about we call that Wi-Fi 6 extended, Wi-Fi 6E? And that's where Wi-Fi 6E comes from. So all of these generational names in Wi-Fi came from the Wi-Fi Alliance. For better or for worse. It makes sense, right? But it's why? Because people will come and say, Artem, we didn't install Wi-Fi 7. Like, why? Well, because 7 is better than 6, isn't it? Like, I guess, I don't know. So it just sounds better. That Wi-Fi 5 is better than 4. And that 6 is better than 5. And now we're talking Wi-Fi 8. And people will come and say like, hey, Pavel, should we upgrade our Wi-Fi now? Or should we wait for Wi-Fi 8 to come out? Yeah, because people just think that's better. So that's where these generational names come from. Well, it happens that Wi-Fi has had several upgrade cycles. Many upgrade cycles. And yes, lately, notice in there, 97 is when it started, and it was 2.4, 2 megabits per second using CCK and different mechanisms. And then in 99, A and B came about with their different abilities and limitations and stuff. And then 4 years later, G came out, and 6 years later, N came out, and 4 years later, AC, and then 6 years later, AX, Boris's favorite standard, came out. And then, like since then, it's been like 2 years, then AX in 6 gigahertz, and then 2 more years, and then BE, and now we're talking about other technology, Wi-Fi 8 coming up, and it's like it's getting shorter and shorter and faster, and people are just pushing and pushing and pushing, and we're gonna get 10 gigs and 46 gigs and 16 special streams, and everybody's just going crazy, and like, how are we gonna compete with all this stuff and learn all this stuff? We're trying to figure out Wi-Fi 6, and then 6E come about, and then 7 comes about, and all this stuff is happening so fast that we just have to keep up. But guess what? The basics have not changed. It's still waves. And that is what people sometimes forget. When Wi-Fi 6 came out, I said, how are we going to design Wi-Fi for Wi-Fi 6? The same way we've been designing Wi-Fi all along. Because waves haven't changed. Waves are the same. And that's what the next session is going to be all about. is about radio frequencies. Now we are an hour and 27 minutes into this. How about, should we go to 2 hours? Then stop right there. I know some of you, it's nighttime for you. If you need how about we take a 5-minute potty break and then we'll come back, okay? Let me pause the recording. Remind me of continue when we, hang on, I think I paused the sharing. Okay, so we're going to pause the recording right now and we'll be back in 5 minutes. All right, and with this, we come to the end of this first free class. I mean, it's going to be a whole class. The official one is like 3.5 days. The Ekahau one that I taught to many of you before, it was like, what, 3.5, Frederick? 3.5, almost 4 days. There was an exam, there were logistics, we had to do this, we had to do that, there was marketing. So it was basically like 2.5 days, almost 3 days of class, and then the rest was just fluff, marketing and stuff. This one, guess what? There's no marketing. There's no fluff. And it's going to be more than 4 days because we're going to spend more time covering some of the subjects that in the official class you just have to rush through because, you know, we have limited time. So not here. Here it's about learning. So this is the end of the first session. There's going to be more to come. All of these sessions are going to be uploaded to this website called the Wi-Fi of Things.com. That's a website I created to upload all of these sessions. Up to this point, there's session 336 was recorded last night with the Spanish-speaking community. Now in that class, we're more advanced. We started back 2 or 3 months ago, and we are doing Hamina wireless design. Look at that. You guys are going to get to this point down the road, I don't know, sometime in the coming weeks, depending on how fast we move. But in this class, we cover some of the spectrum analysis stuff. And then, let me just make sure that this doesn't have, there we go, that's muted. And then we ended up doing some Hamina designs, Hamina wireless. Let me see if I have some of the stuff. Yeah, right there. Like we go through the process of teaching you how to design with Hamina, and I'm going to get you licenses of the software so you can use it and learn how to implement and design networks, multi-story buildings, and all this stuff. So in that class, we're going to have more. This, again, is going to be uploaded to this website, the Wi-Fi-of-Things.com. I'll probably create another link here for the Wi-Fi class in English. These ones are in Español. And we're going to put them together later and kind of like show you the, here, let me see if I have my, where's my WhatsApp? Where did it go? I have an image there somewhere where it has kind of like the schedule of things. Oh, here we go. It's just hidden all over the place. Nomads, give me 1 second. Los feos del Wi-Fi. Give me 1 second, feos. There we go. So these guys. Okay, watch this. This is the sessions that have been done in Espanol. And yes, on that first one we covered IEEE, some basics and regulatory domains and Wi-Fi Alliance. So now we're going to have another session and we'll have the other subjects. We're going to be covering those. So we're going to go through this in English this time, and we're going to have those sessions recorded and uploaded to the Wi-Fi-of-Things.com. We created this group Tesos and Wi-Fi. Tesos is a Colombian word for skilled. Like if you're skilled at something, then you're a Teso, like really skilled at something. So that's what we call the group, Tesos and Wi-Fi. So with this, we get to the end of this first session of the class, the Wi-Fi design class from Wireless LAN Professionals in English. Brought to you 100% free and like 90% in English, right? We had to like mix up some Spanish words here and there. So it's mostly in English, but it is 100% free. So thank you all of you for coming. Now don't leave. We're going to have another session coming up, but this is just for the official recording. If you're not here live, sorry, you don't get to ask questions. You just get to watch the recording and you get to see other guys ask questions. So I guess this is it. Love for free to everybody. I'll see you next session. Have a good one.